Um, I've been with Americase for 13 years and haven't seen any major changes in the regulations for redesigning of our containers when shipping for other customers. But the only regulation that I know of is the ATA 300 regulation that's been around well before I've been in the industry. But there are three categories. There's category 1, which allows you to have 100 round trips. And there's a category 2, which gives you, I believe it's 10 trips. And then category 3, to qualify for that, all you need to do is be able to travel one time. And that's the construction of the case, how you construct it. And within the ATA 300 regulation, there's also a drop test. So to maintain a category 1 status, you need to be able to drop the container 280 times from, I believe it's 30 to 36 inches high, 280 times on its face, sides, and edges. And then upon completion, be able to still lock the case and use it. Category 2, like I said, I think it even goes down further to maybe 80 drops. And then I don't even believe there's a drop test for category 1 because it's just a single use.
Clearly, the tragic example of the value jet incident really drove some regulatory changes. Now that was back in early to mid 90s, and so there was a fire on an aircraft that was started by oxygen generators, and in response to that tragedy, the regulations changed such that you had to redesign containers for oxygen generators to pass a flame and a heat resistance test. So that was the example going back now 20-30 years. So to Steve's point, there's not been a ton of changes recently. However, one of the ones that I wanted to mention absolutely here is related to lithium battery packaging. So there is a industry and regulator kind of initiative ongoing with the SAE. It's called the SAE G27 committee. And the intent of that committee is to put together a standard that is going to require that the package that you ship lithium batteries inside of via aircraft is capable of containing the hazards associated with a thermal runaway. So this standard has not been adopted, it has not been implemented, but there is a likelihood in the future that in order to ship certain types of lithium batteries by aircraft, you're going to have to put it in some type of package that can completely contain the fire, the projectiles, the flammable off gas associated with battery thermal runaway. So that is a regulatory change that, again, has not happened, but probably somewhere in the next 2 to 6 years, we're going to see some major changes as it relates to shipping lithium batteries by aircraft.
Some of the materials we use in our cases could be just standard foam, polyethylene foam, 1.7 pound foam, 2.0 foam, heavy duty foam to protect the product. However, there are some requirements for major customers such as defense contractors that require vibration tests, a lot of drop tests, rain tests to keep water from intrusion. And but other than some of those type of requirements, some of the mil specs that we go through, that's really it that gets put on us for testing and packaging their product to maintain safety.
I'll go back to kind of just to piggyback on top of that, some of the changes that we're seeing in that lithium battery space. So I do a lot of work with lithium batteries, as you can probably tell. It's a topic I like to speak on. And going back to the question here of what standards are going to be driving changes in packaging material. Well, if you're looking at the standard I referenced earlier about having to ship in the future here, having to ship lithium batteries in packages that can contain a thermal runaway. So these standards do not dictate exactly the type of metal, plastic, wood, fiberboard that you can build your package out of. However, they are performance standards. So they say whatever you build your package out of, when we light the battery to thermal runaway, it needs to contain the fire, the projectile, the flammable off gas, all of the hazards associated with battery runaway. So if you're familiar with lithium battery runaway, it can be extremely volatile, very high temperature, flame. And so using some type of package to contain that is not as easy as it might sound. So there's nothing in the standard that prevents you from building your package out of fiberboard. But when you drive the battery to thermal runaway in a fiberboard box, it's not going to contain the hazard. And so when you're starting to drive changes here in the future with packaging materials, if these standards are implemented and widely adopted, we're going to be looking at a lot of packages that instead used to be maybe cardboard, fiberboard, even plastic, are now going to be moving to more outer metal containers, such as aluminum cases that are capable of containing that type of thermal runaway. Oftentimes, the aluminum outer shell, in combination with some of the things Steve is talking about as it relates to some of the more fire-resistant foams and high performance materials such as.
You see, Mike knows all the lithium regulations, and I basically only provide packaging to aviation or the rotary, the oil and gas, the governments. So there's not a lot of regulations other than mil specs that are written in 1950. We have to go by, and so there's not a lot of changes throughout the years of regulations against our packaging. I mean, for example, like the helicopter industry, their mil specs literally was 1956. We'll get a paper in that says it needs to meet these particular requirements, and those requirements are made from wood. And so it's like we don't have to mess with any of those wood requirements because we're aluminum, because they'll have fire retardant paint or things like this, and so we get excused from a lot of those requirements because our packaging is a lot better than what. Yeah, our cases are definitely above code, more than any other case out there. So and again, I always go back to the helicopter industry, because that's one industry that came to us directly because of damages to these $250,000 up to $1 million blades. They're getting punched through the wood or through the fiberglass with the forklifts. So back in 1956 to 60s, maybe wood and that stuff worked perfect and everybody was careful, but now people aren't so careful in transportation, and they will damage a container. So our containers, we like to say we're the tanks and Rolls Royce of all containers. We're sometimes we can be over engineered, but you're definitely getting over that 100 trips that we're talking about for the category 1 with our containers. That aluminum that we use, so when we transfer companies over from wood to aluminum, aluminum is about a third of the weight of the wood. We have noticed that, and so a lot of the airlines switched over to aluminum, not 100% completely, but they are switching over as we speak to aluminum because of the weight issue, which helps with our fuel. With the weights on the plane, the less weight, the better for them. And I think we've talked in the past about how it recycles, and we recycle our aluminum. And the great thing about aluminum, when it's recycled and reformed back into aluminum sheets again, they don't lose the property. It stays the same property it was when it was recycled.
Yeah, and so if you're looking at kind of that environmental profile, Steve's good here about mentioning the recyclability of these types of cases. Obviously, the lightweight, kind of saving on just the total weight of an aircraft, therefore saving on fuel. There's one extra positive environmental impact that we see with our clients is just simply reusability. Like if I'm shipping dangerous goods or not dangerous goods, there's so many people that ship them in cardboard or fiberboard boxes, and as you can probably understand, a fiberboard box is pretty much in all cases a one-time use, meaning that the product goes from point A to point B in the fiberboard box. That fiberboard box is then thrown away. I'm not going to comment on the recyclability of cardboard and fiberboard, but it's not as clean as you might think it is. And so when you're looking at, let's say 100 round trips, you're probably looking at 200 fiberboard boxes, each of them a one-time use. Whereas if you're using a metal container, such as the one produced by Americase, that's one container that's making all of those trips. And so you're looking at certainly significant reduction in just waste that's produced because of the reusable nature of these cases.